Hello guys, and welcome to part 4 of Hello Python, and today we're going to be looking at the second part of data types. This section is called collection types. Now, self-explanatory, what are collection types? Collection types are a collection of different data types that makes sense or has a meaning. A collection of data types that actually has a meaning. So first of all, I've launched my Anaconda Navigator and I have my Jupyter Lab open up here. Now, what are the types of collection types we have there? We have sets, we have lists, we have tuple, and we have dictionary. Now, what are sets? Sets are anything we put within any set of data types or any set of variables or objects we put within parentheses. Not parentheses, curly brackets, sorry, as you can see here. Inside curly brackets, right here. So sets are contained within curly brackets. So we have our fruit basket here, a variable named fruit basket, and it's assigned a set of apple, pear, orange, and banana. Now when I do print out fruit basket, it's going to print the unique elements in my set. So as we can see, we have apple here and we have apple here again, we have orange here and we have orange here again. So when we run that, it's only printing out apple once and it's only printing out orange once, even though in our set we have them multiple times within our set, right? So we can validate that it's a set because it's within the curly braces, right? So we can also define set using a built-in function called set, which Python has. Also makes your work a little bit much easier. You can define between the two which you prefer to use. And it's a function called set, and this function is taking in these characters which I have put in, which is just alphabets. And we can see some of the alphabets are repeating themselves. We have A repeating itself, we have B repeating itself, we have R repeating itself, and we want it as a list. Now, as you can see, we haven't put it inside curly braces because this is a function, so it's within parentheses. But when we do run the function, when we say print A, you do see that it comes out in a set format. So it's in curly braces and that's been split out just like the way in our previous output here, right? Now, sets are mutable, and sets are also, we have mutable and immutable sets. What are mutable sets? Mutable sets are sets that we can change or we can alter. And immutable sets are sets that we cannot change, we can't alter. We normally use the phrase frozen sets. We'll get to that later on. But first, let's look at mutable sets. So mutable sets means it can be altered. So how can we alter? Okay, so based on our previous sets we have here, which I put in these characters, we assign them to a variable named A. So when we print A, it gives us our set output, right? Now I want to add a letter Z to this output. I want to add a letter Z to this set. So how will I be able to add a Z to this set? Since this set is contained in our variable name A, I call my A, which is my set, and I call in a method, the .add method. .add means I want to add something to it. It's a method that it gives you the ability to add content to something. So .add Z, which means that from my set in A, add Z to it. So when we print that, as you can see, Z has been added to our list, right? Z has been added to our set, sorry. Z has been added to our set. So now let's look at immutable sets or frozen sets. Now, frozen sets, like I said, it's even a built-in method in Python, which makes it also easier for you to actually work with. And it's a function, so I just put in these characters into the function. I call frozen set function, and then I put in my list of characters. So this means that whatever I'm putting in here cannot change. We can't modify it, right? But it's still the same set, but you just can't edit the set. So when we say print B, we get a set inside the function frozen set. So it's the same characters there, and remember it's printing out the unique characters. It's not printing every single character within our set. It's printing out the unique characters within our set. So we have another example here called Ghana cities, and we're also calling it as a frozen set, and we're putting it within a list. We'll look at list later on, but we're putting it within a list, but I'm calling it a frozen set. So when I do print out Ghana cities, I get a frozen set, and instead of it coming in the brackets in which it was, it's now coming back as curly brackets, because it's now taking it as a frozen set. It's a static, can't alter, can't change. Now the next collection type I want us to look at is a tuple. Now what's a tuple? Tuple is anything within parentheses, right? So here we have two examples here. We have tuple 1, which is our variable name, and we're assigning these values into it, which is a numeric type of 1, 2, 3 and a string type of hello. So you can see these are different data types. So we can contain different data types inside tuples as well. And we are assigning it to a variable name tuple 1, right? So if I do print out tuple 1, we should see 1, 2, 3 and hello, which are the values stored inside our variable name, right? Okay, so fine, we understand that tuples are immutable. It means they cannot be modified, but that doesn't mean that we can't call from it. If I want to extract something from a tuple or a set or a list, I should be able to do that, even though it's immutable. Yes, we can't modify it, but we should be able to extract information from it, right? So how will we do that? We'll do that by something called, we can actually call it by its name, and we can also do indexing, but we're going to do indexing for this one, and then later on we will use the actual name, so, or the actual object, actual name of the object, or the actual object itself. You can actually call it from there, but we're going to use indexing. So what's indexing? Indexing is a way when we store things in memory, it stores it starting from 0 and upwards. Indexing starts from 0 and upwards. Numerical counting starts from 1, 2, 3, 4, 5, 6, 7, but indexing we start from 0. 0 is very important. 0 is key. So in our tuple here, we have two objects in there, right? So the first object is 0, then the second object is 1. So the index of the first object is 0, and the index of the second object is 1. Right. I hope that's not too confusing. So we give an example. So if I want to call out an object from the tuple, how would I go about it? Well, I'll call the variable name in which contains the object I want to pull out, which is tuple 1. Let's comment this one out. Tuple 1. Then I put it within brackets, right beside tuple 1, no space, tuple 1, and put the brackets. Means I want to get something within you, or I'm looking for something within. It could be a column, it could have been a row, depending on the type of data structure in which you have. But here we only have two objects within our tuple. So I want the index of 1. If I want the index of 1, which one do you actually think would print out? You guessed it right. It's going to be hello. Why hello? Remember we spoke about indexing. So if I want to call out a variable using the index, indexing starts from 0. So in case I wanted to call out the first index or the first object in our tuple, I would say 0, right? And when I run that, I should get 1, 2, 3, which is the first object there, right? All right. So like we said, we can't modify. So this is a way of modifying objects, or actually pushing something You know, in programming we have something we call push and pull to actually store something in memory and pull something out of memory. So this is almost like a push in memory kind of way, and we are trying to do that to a tuple, but it wouldn't work because it's immutable. And I want to just give one example of it so you see when you actually hit such an error, you should understand what it's actually saying. Because when you program, you're always going to run into a lot of errors and bugs, so we need to run into some of them to actually get familiarized with it. So when you do hit a bug and you're like, oh, I remember that, you can revert and do what you need to do. So again, I'm calling my variable name, which is a tuple, which holds these objects, and I'm saying from index 1, which is hello, I want you to assign it change. But when I do assign it change, when it's done running, it should hit an error. What is our error? What's our type error? Our type error says tuple object does not support item assigned. It means what you're trying to assign to this tuple is not supported. You can't do that. So that's an error. So if you do hit something like this, you should know what it's trying to tell you. So moving away from tuples, let's go to lists. Now what are lists? Lists are anything that are put within brackets. So example of our list is here. We have list 1, which we've assigned a list of different data types or different objects within it. And when we do print that out, we do get the same values out, right? Still in their brackets because it's a list. Here's another one, another example of a list. We run that too, we get hello and hello Python. So the list actually works. Now, can we actually do mathematical operations on a list? If we actually add list 2 to list 1, would it work? Think about that for a second. Let's run that. And yes, it should work. What is it doing? List 1 and list 2 are concatenating. We are adding them together. So we are saying print list 1 and print list 2 and add list 1 to it. So it's printing out list 2 first, as we can clearly see, and it's adding list 1 to it. So we can actually do a mathematical operation or a common operation on lists. So we've added one list to another, and it's concatenated the list into one list, 2 lists into a single list. And we can also multiply the lists. Will this work? Yes, it would. So it actually prints out our list twice. Here's the first one, and then output of the second one. Okay, now I just want to pitch in something we call a slice operator. Now what's a slice operator? A slice operator is a way of, instead of just pulling from index one value, I can actually, because it's a list, I can actually take out a range of values. Now we can do that by a specific range of values. We can do that by using the slice operator. Now what the slice operator does is uses a colon. Now the colon depicts a start, a stop, and we even have a third one, which we're not going to get into, but it's a step. So the first one is your starting position, the second one is your stopping position, remember, and the third one is a step. So when we use the step function, then we're trying to do something called an iteration. We'll look at iteration in the upcoming videos, one of the upcoming videos. We'll get into iteration, but this slice operator is another way of doing an iteration. We can actually step over one. We'll look at that later. So let's actually look at the basics. So take care of that. Okay, so what does a slice operator do? So using this colon, it depicts that where do you want to start and where do you want to end. So I want to go into my list 1, and I want to slice starting from the beginning and taking out the third. What am I saying, really? Okay, remember we talked about indexing, and whatever is stored in memory or in your variable name is indexed. So when we say start from 0, we are saying start from 0, 1, 2, and end at 3. And when it ends at 3, it does not add the third one. It actually cuts it off. So you're slicing it at the third position. So it's taking 0, 1, 2, and slices it at third. So when we print this out, we can see that clearly. It takes 0, 1, 2, and slices out the third. So if we want the third one in, we can just quickly put in a 4. So that's 0, 1, 2, 3, and cut it off at 4. So this should print out our whole list, and voila. we get our whole list in. We could actually do this without, since we are starting from the beginning, we can actually leave that blank. By default, it understands that it's empty, so it's a 0. So if we run this operation, we should still get the same result. Now, what if I want to slice from, probably, I want the first one off and start from the second to the end. From the first position, from your start position, I can put 1. So start from 1 all the way to the end, right? And when we run that, we see that it slices out the first one all the way and leaves the rest in. So that's a nice intro into slice and how we can use it in a list. And we'll look at it further later on. Right now I want us to move into dictionaries. Now, what are dictionaries? Dictionaries are sets, or a type of sets that take in key pair values. What are we saying? Remember, the sets are put within curly brackets, right? But the difference between the set and a dictionary is that we put in a key, which is the first, and then we put in a value. And it is denoted by the colon in between. So the first one is always the key in a dictionary, and the second one is the value. You basically see this sometimes in JSON files and whatnot and what forth. You don't really get key pair values, and we'll work on that not in this series though, but upcoming series. So let's get back. Dictionary deals with key pair values. So this is the key, which is our name, and our name contains red. We have our age contains 10, right? So if I should print out my dictionary, and remember this is, okay, let's run that first. Okay, so we get our set, which takes in a key pair value. So that's the only difference between a set and a dictionary. It takes in what? A key pair value. If there's no key pair value, then it is just a plain set. But if it takes in a key and pair value, it is upgraded from a set to actually a dictionary now, because it's having a dictionary of whatever you put inside. Okay, so remember we spoke that whether it's immutable or mutable, we can extract information we want from it, whether it's been a set, list, dictionary. So how can we do that? Remember, in our first instance, we used indexing to extract, but this time we're actually going to call by key, right? So in our dictionary that we've set over here, remember this is our dictionary and it has key pair values. What are our keys again? Which is our name. So if I call my key, what should we expect? When I call my key, I expect a value because it's a key pair value. So instead of indexing, saying indexing from 0, I'm actually calling the key. I start by calling my variable name dic, and then I put it in brackets and I call the key, which is name. So when I do print that, it should give me my red, which is the value red, which is assigned to this key name. So when I print out name, I do get out red. Now it's actually quite cumbersome actually if you have a large list, actually going into it one by one. What if this is actually a small dictionary? Really, you'll be dealing with larger sets, real life data, you're dealing with larger sets. So what happens if I just want to see what are the keys in my dictionary, what are the values in my dictionary? We can do that by saying print dict, which we're calling our dictionary, dot values, which is a method. So we're calling the method of values, which is going to pull out or extract the values from our dictionary for us. So when I print values, it tells us my dict values are red and 10, which is true. Values red and 10. Okay, fine, I know my values now. So what about my key? Same way, but the only thing that changes is dot keys. So dict dot keys method, and what do we get? It prints out our keys. So now this brings us to the end of dictionaries. I just want us to recap. We've looked at data types from the first video, and we looked at integers, we looked at booleans, we looked at strings, and then we are seeing how we can work with them in collection types, which are sets, lists, tuples, and dictionaries. And we've seen how the various types and what we can actually do with them. I hope you really like this video. If you do, like, subscribe, and I'll see you in the next video.